All right, so now we'll go ahead and begin again. And we're going to now finish up 2.3. And if we have time, we might also be able to get through 2.4 because it's a shorter section. We've got one more part to go through in 2.3 today. And that's another flow chart. 2.3 is by far the most difficult section because there's just so much in here that we have to go through. So 2.3 is definitely the most time consuming. After this section, it's a lot easier. So we're still in 2.3, and we're going to find the line equation again. And you're going to be given a point. And an equation. Okay, so we're going to find the line equation, just like we did before. But this time you're going to be given a point and a line equation. Now we do need to make sure that we get the slope, because we always want to go back to point slope. So how do we get the slope from an equation? Well, we have to solve that for y. So that's going to be our next step here, or our first step, is we solve that equation for y. And that gives you y equals then mx plus b. And we want m, the slope. Now this one's a little bit different, because this one's going to have different options. This goes back to when we looked at line equations and we compared two line equations. They could be either parallel or they could be perpendicular. And the same goes here. The directions will say either parallel or perpendicular. So let's remember what those mean. So if we want the parallel slope, if these lines are parallel, that means they have the same slope. So we use the same slope. So if it's parallel, we use the same slope. And the other side is going to be if it's perpendicular. And if it's perpendicular, we use the opposite reciprocal slope. So let's look at an example here. Put this up so we can see. An example would be m equals 5 and minus a fifth, or m equals, let's say, 2/3. Your slope would be negative 3/2. Okay, so those are just examples here. So perpendicular, we want the opposite reciprocal slope, or negative reciprocal. And then where these lead to is they lead back to point slope. Either way, it's going to go back and you're going to have to use point slope. Which is y minus y1 equals m times x minus x1. And then we can either write our answer in standard, or we can write our answer in slope-intercept form. Slope-intercept form is y equals mx plus b. And standard form is ax plus by equals c. It looks more confusing than it actually is. As long as you follow this flow chart, you'll be fine. We'll try to work through 2, maybe 3 of these if we need to, and then we'll look at some special cases. And then if we have time, we'll move on to 2, 4, when we may or may not have enough time for that. And these are not that difficult, they're just time consuming. And you have to make sure you follow that flow chart and those directions precisely here. So let's find the equation. In, let's say, standard form. And you're going to be given the equation, how about 5x plus 3y equals 7. Parallel to this point, 4 minus 1. So we need to make sure we know what we're doing here. So it's going to pass through that point, and it's going to be parallel to that equation. So what do we need to do first? Well, we need to find our slope first. So to use that point slope formula, we have to find our slope. We can either use a formula if we have 2 points. In this case, though, we can find the slope by solving for y. So let's take our equation and solve for y. So we've got 5x plus 3y equals 7. I'm going to move that 5x over. That leaves me then with 3y equals minus 5x plus 7. Divide by your 3 everywhere. And now we have y equals minus 5/3 x plus 7/3. And m is minus 5/3. That's your slope. And that just came from there. Now, once you have your slope, then what do we need to do? We need to see if it's parallel or if it's perpendicular. So this one says parallel. So what does it mean if it's parallel? Do we change the slope at all? No, we keep the slope the same. So parallel means we keep the slope. So we're going to keep the same slope there. So we're going to be using that minus 5/3. So what did we do first? Let's review. We took our equation, we solved it for y, we got our slope. Then we went back and we read it, and the key word there is parallel. So for the parallel, we're going to keep that slope the same. Now we move on, and what's it say to do? Okay, let's see where we're at. Thank you. So we were right here. We took our equation and we solved it for y. And then we got that slope and we said it was parallel. So we used that same slope. And where does it lead to? It leads to point slope. So what are we going to use next? Okay. Next we're going to be using our point slope formula. So we have our slope, and we're going to use that point. So we're going to use point slope. And we've got that slope that we found to be minus 5/3, and the original point was 4, -1, so that comes back here. Okay, so now we're going to use that slope that we found. We're going to use that slope along with our point. And we simply label x1, y1. I always like to write our formula down. I think it just makes it easy to remember if you write it down. So now we're going to use point slope, which is y minus y1 equals m times x minus your x1. We fill it in, and so we've got y minus, or minus 1 equals minus 5/3 times x minus 4. Now we should know what to do, because we've done a lot of these already today. So now we're at our last step. So we found our slope from solving the equation for y. It was parallel, so we kept the slope the same. We used that original point with the slope that we found in our point slope formula. And now we're at this step. So we're almost done here. This double negative makes that positive. And then we're going to distribute this minus 5/3 through. So that leaves me then with y plus 1 equals minus 5/3 x. Negative and negative makes it positive. 5 times 4 makes it 20 over 3. We're making progress here. Now, we want this in standard form. So, in standard form, can we have a fraction? Nope, so we need to clear out our fractions, because we want this in standard form. And what standard form looks like? The x and the y are on the same side. So let's begin by clearing out our fractions. So multiply it all by 3. And that leaves me then with, we'll move that over. That's going to leave you now with 3y plus 3 equals, 3's cancel, minus 5x, 3's cancel, plus 20. Add your 5x, subtract off your 3, and now we are left with 5x plus 3y equals 17. That is in standard form. So that's in standard form. It just takes a bit of time to go through these. They're not really difficult. It's just using the flow chart. Make sure you don't make an algebra mistake. That one was parallel. Let's do one now that's perpendicular. So let's find the line equation. In slope-intercept form, we did the last one in standard. So we'll do this one in slope-intercept. And you're going to be given a point and a line equation. So let's see, you're given the line equation. Well, let's say 4x minus 3y equals 2. And we want this one to be perpendicular. And we'll use the point -1, 8. So this is what we've got here. So we've got a line equation again. In this case, we want it to be perpendicular. Now, nothing else really changes except when we get our slope. When we get our slope, we have to change that slope. Everything else stays the same. What do we have? We have a line equation and we have a point. So that tells me that I am going to use that third flowchart, the one that we went through just a moment ago. So what's the first thing we do? We take that equation and we solve it for y. So 4x minus 3y equals 2. And we need to take this equation right here, and we need to try and solve it for y. So move that 4x over. And then we've got a minus 3y equals a minus 4x plus 2. We'll divide by our minus 3 everywhere. And then that leaves me with y equals now 4/3 x, and it's positive, minus 2/3. And so my slope is 4/3, because that comes from there. But is that the slope we're going to be using? No. Why not? Because what does it say? Perpendicular. Okay, so we found our slope, but we're not going to be using that. We want the perpendicular slope. So we want that perpendicular slope. And so we're going to be using then m equals now negative 3/4. Because that is your perpendicular slope. So we wanted the perpendicular slope, so we used the opposite or the negative reciprocal. So we changed our sign, so that positive became a negative, and then we flipped our fraction over. Now we should know what to do. From here, now we start the process of using our point slope formula. So now we use point slope. And we've got our original point, which is minus 1, positive 8. And we're going to be using that slope of minus 3/4. So go ahead and fill these in. Y minus y1 equals m times x minus x1. And our ordered pair is x1, y1 here. So those will get filled in. And that's going to then be y minus 8 equals now minus 3/4 times x, and watch your double negative, minus a minus 1. Move it up here. Sorry about that. Okay, the double negative here makes that then positive, and we're going to distribute it through. So y minus 8 equals minus 3/4 x. Negative and positive makes it a negative 3/4. And we still need to go ahead and get this in slope-intercept form. So we need to go ahead and clear out those fractions. So we'll multiply everything now by a 4. That'll clear those out for us. And that is then 4y minus 32 equals a minus 3x minus 3. We want it in slope-intercept, so we're just going to move that 32 over with addition. And now we've got for y equals a minus 3x plus 29. We'll divide this by 4. And now we've got y equals minus 3/4 x plus 29 over 4. And that is your answer in slope intercept form. Okay, we do have a couple of special cases to talk about next, and these are very, very simple to work through. We need to make sure we understand this next concept. These are kind of like what we did right before break, where was not much to do. We need to talk about parallel and perpendicular lines when it comes to x and y. We need to note these facts. X is parallel to x. Y is parallel to y. And x and y are perpendicular to each other. So x is going to be parallel to x, y is parallel to y, and when it's the x and the y, they're perpendicular to each other. These next ones are very, very simple. There is not much to do to these at all. It is just like what we looked at before break, just a little bit different. Let's go ahead now and find the equation. And let's see, you're given x equals 9 parallel to 4 negative 8. Yes, yep. So what does this one want? And I know this is kind of confusing, but it's very simple once you understand the concept. Okay, so this one's parallel. Now, when it's parallel, you keep the same variable. So x is going to be parallel to x. So I've got x equals 9, and I want another line that's parallel to it. Now, an x line would look like this. So what's parallel to an x line? Another x line, okay? So this is parallel, so that means that it's going to be the same. And so what's the x component? 4. So what would my answer then simply be? X equals 4. See, there's very little to do on these. Let's try another one. Let's find the equation. And let's see, you're given y equals negative 8 perpendicular to 1, 4. Okay, so first off, we need to figure out, we've got y equals negative 8. So that is a horizontal line. So what's perpendicular to a horizontal line? A vertical one, right? Okay, so what is it going to be for the variable? Is it an x line or a y line? Which one? X and y are what? Perpendicular, right? So if I want to be perpendicular and it's a y line, what would this one be? Would this be an x line or a y line? Which one? Okay, perpendicular means we look at the opposite. So this is a y line. So what's the opposite of that y? It would be what? x, and in this case it would be x equals what now? X equals 1. That's it, because it's the x component. One more, and then we'll look quickly at 2.4. Let's do one more of these. And these are easy, and you'll probably see one of these on your exam because there's not much to them. Let's go ahead and find the equation. And let's see, you're given y equals 10. Parallel to that point, 8, negative 1. And again, what's the key word here? Parallel. What does parallel mean? The same. So this is a y line here to begin with. So my answer is going to be another y line. And what's that y line going to be? Can someone tell me what it will be? Y equals what? I'll look at my ordered pair. What's my answer going to be? Y equals a negative 10, right? Because that's your y component of that line. So there's only a couple of these in your homework, but I wanted to make sure we went over them. And I'll probably put one or two of these on the exam because they're easy points. As long as you can remember, when we talk about x and y, x is parallel to x, y is parallel to y, and x and y are perpendicular to each other. Now we can move on, and we'll see how far we can get in 2.4. We may be able to get through all of 2.4 today because it's a shorter, easier section. 2.4 is graphing inequalities. And this is much easier, I think, than the last section. And so we're going to be graphing inequalities. When we graph inequalities, a strictly less than, strictly greater than, those don't get parentheses anymore. Those get a dotted line. Greater than or equal to, less than or equal to, those are going to have a solid line. So we're going to be graphing these inequalities. And they're either going to have a solid line or they're going to have a dotted line, one or the other. And we're going to start off with a very easy one. And let's go ahead and graph y equals 3x minus 1. And, well, let's not make it equal, sorry. Greater than or equal to. We're trying to do inequalities here. So let's say it's greater than or equal to. We want to graph this line. Now, if I want to graph this line, I need to make sure it's in slope-intercept form. Is it in slope-intercept form? Has it been solved for y? It has been, hasn't it? Okay. So, what's my slope? Let's find that. It's already been solved for y. So, my slope would be what? 3. Number in front of the x. And what does this represent? Well, that represents your y-intercept, and that's that point 0, negative 1. Now we have everything that we need to graph it. This, by the way, is a greater than or equal to, so we're going to have to use a solid line. Remember how to graph these lines. We start with our point, that y-intercept. Right there is our y-intercept, and that's at 0, negative 1. My slope is 3 over 1. So that means we have to go up 3 and over 1. So we start here, and we go up 3 units. So we go up 1, 2, 3. up 3, and then we go over 1. And we make our new dot, just like we've done before. Now we connect them together. The only new part is the shading. So we're going to have to shade. So we're at this point. We need to pick a point that's not on that graph. Any point that you want, does not matter. Just pick something that's easy. Doesn't matter what you pick. You could pick 0, 0, or any point. I'll just pick an easy one that you can make sure you know where it's at. So let's say I pick -3, 0. And that's right back here. You can use any point that you want. You can use 0, 0. You can use 4, 4. As long as it's not on that line, you can use it. But try and make it as easy as possible. -3, 0 is clear back over here, and I know where it's at. So I'm going to check out that -3, 0. Just make sure your line is not, or your point is not on that line. So let's check -3, 0. And we're going to check that in the original. We're going to check it in. Remember, this is your x and this is your y. And we're going to see if this is true or false. So 0 is greater than or equal to 3 times a -3 minus 1. 3 times a -3 is a -9. Minus 1 makes it a -10. And is 0 bigger than a -10? Is that true or is that false? Is 0 larger than -10? Well, that would be what? That would be true, wouldn't it? Now, what this does is this tells you which half you're going to shade on. So -3, 0 was true. So that means this half is true, and the line separates the two regions. So since that was true, we're going to shade above the line like that. If it was false, we would shade down here, because this half is true, and this half must be false, and we shade the true half. So you pick a point that is not on that line. And you can use 0, 0. You can use any point that you want. A lot of times I use 0, 0. But again, does not matter what you pick, as long as it's not on that line and you know where it's at. Let's try another one. Let's try and graph this one. Y is less than -4. Okay, we talked about Y lines a lot. What do we know about Y lines? Are they vertical or are they horizontal? Which one? Vertical or horizontal? Vertical. Not vertical. Remember, Y lines are going to be what? Horizontal. If you forget, find out where that -4 is at. Okay, -4, Y is less than that -4. That's going to be down here, right? It's a Y part. This is your Y axis. So it's going to be there. So I know then that my line has to be a horizontal line. And it's going to have a dotted line. Why is it going to have a dotted line? Well, it has a dotted line because strictly less than, strictly greater than, see, those get a dotted line. So that one has a dotted line. Now we need to go through the process again of checking. And we can use any point that you want as long as it's not on that dotted line. Doesn't matter what you pick. We can see it easily, so let's check 0, 0. And let's see if 0, 0 is true or false. So we're going to try and check 0, 0. And Y is less than -4. So that means 0 is less than -4. Is 0 smaller than -4? Is that true or is that false? That would clearly be false, right? So what does that mean? That means this half is false, the lower half is true, and where do we shade? The lower half. Enough time to do a couple more examples. Let's try and graph this one. Let's try and graph y is less than negative 5x. So y is less than negative 5x. Okay, so we need to graph this one. Where do we start at? Well, what does this negative 5 represent? That's your slope. There's no number on the end, so that means no number. That's like having a plus 0. So if there's no number on the end, it's like having a 0, 0. And that's where we're going to start. So we're going to have to start at 0, 0. Are we going to have a solid line or a dotted line? Can someone tell me which one I would have here? Solid line or dotted line? Dotted line. Okay, so we're going to start at 0, 0. My slope is a negative 5 over 1. So that means we go down 5 and forward to the right 1 unit. So we're going to go down 1, 2, 3, 4, 5. And then we're going to go over 1. Make our new dot. Sorry about that. Now we can connect them together with a dotted line again. I cannot check 0, 0. Why not? Because 0, 0 is on that dotted line. You need to make sure that whatever point you pick is not on that dotted line. So I can't use 0, 0. So let's just pick another point. Let's just pick 5, 0. Again, you can use any point that you want. Just make sure you know where it's at in relationship to that line. So let's go ahead now and check that 5, 0. And our original is y is less than a minus 5x. So that means 0 is less than minus 5 times 5. So minus 25. Is that bigger than 0? Is minus 25 bigger than 0? Clearly that again is what? False. And so that means then this half is false up here, because that's where your point's at, right there. The other side must be true. And where do we shade? We shade the true side. I think we have enough time to do a couple more of these. Just to get through this section. So let's try another one here. And let's try and graph 4x minus 2y is less than 8. Now let's make it less than or equal to, because we've done a lot of less thans and greater thans. Let's do a less than or equal to. So this is what we've got. Now I want to graph this line, so I need to get my y-intercept and I need to get my slope. How do we do that? Well, we need to take this. It's not been solved for y, so that means we need to first solve it for y. And so we've got 4x minus 2y. We'll make that equal 8. We'll move that 4x over. And then we've got minus 2y equals minus 4x plus 8. We'll divide by our negative 2 everywhere. And now we've got y equals, and we reduce 2x, and 8 divided by negative 2 makes it a negative 4. So we are going to be checking back in our original number. So if it hasn't been solved for y, then you need to solve it for y. So go ahead now and solve it for y like we did here. Once we have it solved for y, then our slope is 2, and our y-intercept as an ordered pair would be 0, negative 4. So solve it for y if it hasn't been. Then once it's been solved for y, we can graph it. Because what do? We take and plot our ordered pair. 0, negative 4. So we'll plot that point. So we'll plot that point. 0, negative 4. And then we'll use that slope of 2. We're going to use a solid line to connect them together. So let's find that point, 0, negative 4. And that's right here. And then from that point, our slope is 2 over 1. So we go up 2 and over 1 from this original point right here. We go up 2, and then we go over 1 unit. And that makes our new dot. Connect them together with a solid line in this case. And now we need to pick a point to check. Doesn't matter what we check. Easy to pick, 0, 0. We know clearly where that's at. It's way above the line. And now we need to check that 0, 0. And so we're going to check that in. 4x minus 2y is less than or equal to 8. We plug our 0 in for both x and y. That gives you 0 here. And is 0, is that smaller than 8? Is that true or is that false? Is 0 smaller than 8? Yes, because 8 is bigger. So that would then be true. So this half is true, this half is false. Where do we shade? The true half up there. I want to look at one of these from our homework, because some of these are already done for you for the most part. Let's look at question 3 in your homework. Now, some of these are already done. On one like 2 in question 3, the line is already drawn. Okay? We don't have to graph it. All we have to do on 2 and 3 is shade it. And there's several others like this too. So on question 3, we'll focus on question 3 here. And this is 2.4 in your homework. All we have to do is shade it. So we need to pick a point that is not on that line. Doesn't matter what we use. Well, I'm going to use 0, 0. And let's check that 0, 0 in my original equation. So I've got minus 3x minus 4y is less than or equal to 12. We're going to plug in that 0. That's gone, so I've got 0. And is 0 smaller than, or sorry, make sure we said it right, is 0 smaller than 12? Or 12 bigger than 0? Yes, it is. So that would make this then what? True. So this half is true. This half is false. Where do we shade? The true half. So that's all I want for your answer on those. Some of these you already have the line drawn. And all you need to do is pick a point, not on that line, and check it to see if it's true or if it's false. All right, so that's all you need to do on 2 and 3, and there's several others like this as well. You should now be able to get through 2.4 in your homework. So what's our homework? I'll try to move this so we can keep it up on the screen if we need to. What's our homework for next week? Well, our homework for next week is this. We've got the right spot here. That way it keeps that up on the screen for you. Your homework for next week is 2.3. You should be able to do them all now. And 2.4. You should be able to do them all. So I will see everyone next week. And your homework is 2.3 and 2.4. And we'll have plenty of time for questions out of 2.3 next week, because I know we'll have some when you work them out. Some of those are a little bit tricky, and it's easy to make a mistake on. So your homework is going to be 2.3 and 2.4.